The concept here is to design a faceted box that's got a unique shape and would be easy to manufacture. The manufacturing method we want to choose should have no tooling, and it should be scalable from low quantities up into high quantities, maybe even reaching thousands of parts. But we want to start out as inexpensive as we can with very low initial costs. So to do this, we're going to create this box out of sheet metal. That's cutting something flat and bending it into shape. So this design looks like it has a faceted shape that, if we were to extend this top surface up, would consist of two rectangles. The square base at the bottom will be roughly 4 inches, and the overall shape might be as high as 5 inches, but we're not sure exactly how far we want to cut it down to get this look. So in our CAD system, we can start sketching on the top plane. This viewpoint would be as if we dropped our part or box on the tabletop and we're going to build it up from the tabletop. We'll start a new sketch, and I'll just pick a rectangle. So we can pull this down and click for center rectangle, and here's our center rectangle. Now in this case, it'll be a square base, so I can control select two adjacent sides, and we'll set those equal. We'll add a dimension, and 4 inches seems reasonable. Now I'll close that sketch. And the idea here is that we've got the top plane. You just saw me rotate these planes around, but I haven't described how to do that. If you hit the space bar, SolidWorks will bring up this cube that's very similar to something you'll see in Autodesk products. It also brings up this little menu here where you can pick different views. So the space bar is going to bring up either one of these, and you can hit any view you want from the space bar. You can also rotate this around by holding down the mouse wheel. So if you hold down the mouse wheel and pan the mouse, that is, move the mouse around, you can see that we can look at all angles of this. And basically what we're doing is rotating the camera around our part. So this represents the top plane or the tabletop, and we want to build the part from there. So a pro tip that's rarely in the textbook is if I take an existing plane and select it, I can control drag on that plane and create a new plane in its place. So the distance here, D1, we're going to set to 5, and that's going to be our offset distance of 5. We'll click the green check to go, and as I roll the mouse wheel, it will zoom out. Or you can hit the F key. F is fit to screen. Now, just to show what's going on, we've got the tabletop. I'll show that plane. There's tabletop. Here's plane 1, and we want to start a new sketch on plane 1. But a little pro tip that again is rarely in the textbook is that I can duplicate that initial sketch on top of this new plane. So if I control select these two things and I hit the S key, S is for shortcut, but it's also for search, I can look for derived sketch. So here we have insert derived sketch, and what it's going to do is duplicate my first sketch, which was sketch 1, into this new plane. Now if I look straight down, so we can hit the space bar and just click on the top of the cube, we'll look straight down. I'll click and I'll drag this new rectangle off. If I click once for that center point and then control click where the origin would be, then I should be able to set this coincident. And what that will do is lock the centers together, but I can still rotate this new plane. Just to show what we're doing in three-dimensional space is I am able to rotate this top plane. We'll look straight in again by hitting the space bar and going to the top of the cube. We'll select a dimension, and that's kind of hard to do right now because it seems like I'm stuck on a plane. But we can grab the Smart Dimension tool from the toolbar, and we'll dimension from the existing sketch to our new sketch, and that's going to be 45 degrees. When the new sketch turns black, that means it's fully defined, and we can close that sketch. So here I have the top plane representing the tabletop. We've got a rectangle on that. We created a new plane, which is plane 1, and we duplicated that sketch into the new plane. We also rotated that plane that sketch 45 degrees, so now I have what might be my faceted shape. We'll hit the S key, S for shortcut and S for search, and we'll look for loft. A lofted boss base is going to create an organic shape between the rectangle on the bottom and the rectangle on top. And here is our rotated shape. Now it doesn't matter if we want it to twist clockwise or counterclockwise, because we can adjust where these drag handles go, and that will change our twist. So this looks good. We've got it twisting one direction or another, and when we click the Go button, this should represent our box, but it doesn't quite represent our box. So if I go back to the picture, I'll see that this really consists of flat panels. So the MFI panel here is flat, and the PCC panel is flat. If I were to count the number of panels all the way around this box, I would see that there are 2, 4, 6, and 8 panels around this box. But my CAD model only consists of 1, 2, 3, and 4 panels. Another thing you might notice is these vertical panels are not flat. They're technically curved, like a cylinder or a saddle shape. So this isn't going to work for sheet metal. This lofted idea is not a sound idea. It's not the right tool that we want to use. So on the loft one, I'll right click and delete that. The nice thing about SolidWorks, when I delete a feature, it keeps all of the sketches and reference geometry in place so that I can use them again. So let's look again at our original concept. Our concept is a flat panel here for MFI and a flat panel here for PCC. These are flat triangles. If we were to extend this box up, we may even see that this vertical line and this vertical line would converge up here at the top, just like the PCC box converges down here at the bottom. So I need to create a set of triangles. Those triangles are going to be flat panels, and there's really no way for me to do that with a primitive solid tool.